Here's an interesting problem you may or may not have seen before. It's called the birthday problem. The idea is you want to know something about, if you have some number of people in a room, what's the chance that say two or more of them will share a birthday? Okay, so here's how we can think about that. First of all, envision a calendar. Okay, here's January 1st, and here's January 2nd, January 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, etc. all the way around until you get to December 31st. Okay, here's my calendar. Okay, I got all these days in the year. Okay, so what is the probability that, say, if you have one person, what's the probability that one person has his or her own birthday? Well, that's one, right? That's a pretty stupid question. But what's the chance that if you have two people have their own birthdays? Okay, well, let's see. First of all, if I take the first person and drop that person somewhere on here, where does he fall? Okay, maybe that's his birthday. Okay, November 11th. Okay, once I've allocated that day, once I've assigned that birthday to that individual, the second person has how many different ways to have their birthday that are different? The number of all the other days. How many days are in a year? 365, right? 365 or 366, depending on whether or not it's leap year. So, here's a simplifying assumption that we'll do. We'll just assume that there are 365 days in a year because, hey, you know what? Raise your hand if you were born on February 29th. That's right. That's right. See, I don't see any hands going up. So, we'll just throw those people out. They don't matter anyway. Just kidding. But oftentimes, this is what people do. They make assumptions that'll simplify our calculations, but we could certainly do it, including people born on February 29th. It would just make the solution a little bit more difficult to work out. So we'll assume that there are 365 days in a year. Then, if I have two people, how many different ways can I assign them birthdays? Period. 365 times 365, right? Yeah. Then, right. But now if I want to count the number of ways that I can assign them distinct birthdays, well, the first one I can drop down in any one of 365 places. The second one then, 364 ways to assign that person a birthday once I've assigned the first person. Okay? But now what's the chance that three people have their own birthdays? Well, guess what? 365 times 364 times 363 all over 365 to the third, right? So in fact, the chance that n people have distinct birthdays, let's see, it's going to be something over 365 to the nth, isn't it? Yeah, in fact, and I think what I could do is maybe I could write this as 365 times 364 times ... 365 minus n plus 1. Okay? Yep. And that's the answer to that problem. Then now, what is the probability that two... Well, now let's write it like this. Let's write it over here anyway. What's the probability that if you have n people are in a room that two or more share a birthday. Okay, this can be written then as 1 minus the probability that they're all distinct, right? So it's 1 minus 365 times 364 times ... times 365 minus n plus 1 all over 365 to the nth. Now, in the very next thing there on the course web page, you'll see an Excel file where I've actually carried this computation out. You'll see in one column I've got the number of people that are in the room, and then in another column I've computed the chance that they share a birthday, or that there is a match, at least one match. You can see, of course, as the number of people in the room gets higher, this chance is going to get higher and higher. In fact, of course, if you have 365 people in the room, then the chance is 100%, right? Unless it's on a leap year, yeah. But we're assuming that we're not doing that. But, okay.